Okay. Bum, 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 bum. Okay. Animation, the illusion of movement by playing back a series of frames. That's been accomplished a couple times. When we think of animation, we probably think of Disney, right? He actually wasn't the one who invented the process. It started with a dinosaur movie in, I want to say 1896, sometime in the late 1800s. But you've seen flip books, right?
Mm-hmm.
And that's the same thing. We're giving the illusion of movement by playing back frames. In the beginning, it was a very tedious process. What we actually had to do is we would draw out the important scenes. Okay, as this is an important scene, this is an important scene. Those would be our key frames, our important frames. Then we would hire somebody else. You ever remember, and some of y'all are old enough, in the back of comic books it said, if you can draw this, you may have a future in animation. We'd like to talk to you. Because they want you to be, they want to find people who can look at something, recreate it in multiple sizes, very realistically. Because what they would do is, the keyframers were the lead animators, and then they'd hire in-betweeners to figure out how, over the course of time, that has to take place. And if you ever go watch some of the makings of, you'll see them flipping through and making little changes here and there. Yes, sir?
This would be the pose-to-pose principle, right? Pose-to-pose.
Yeah, yeah, pretty much, yeah.
Okay.
But so we would have to sit there and fill all that. So we had the keyframers. Disney's famous for the 9 Old Men. They were the main keyframers for a generation of Disney films. And they had hundreds of people who would sit there and do the in-betweens. And then we came up with stop motion. First stop motion I ever did, a friend was studying video sometime in the early 80s. Camcorders made stop motion something that we could actually play with. And there we're taking a frame, moving an object, taking a frame, moving an object, taking a frame. And the one that we did, a local bar locked me and Danny into the bar after hours so we could animate the liquor bottles dancing and whatnot, and the agreement was we would not leave until the manager came in the morning to let us out. And so we spent all night making liquor bottles dance, and I think we got 30 seconds worth of video over the course of about 8 hours. Just one movement. Let's add some drops to this glass as it fills itself up, and then let's remove those. You know, it was interesting. I didn't realize, 30 years later I'd be studying it and understanding it. I just, was helping out a friend is what I thought. But that was stop motion, and probably the classic stop motion is Nightmare Before Christmas.
Mm-hmm.
If you ever go and get the chance, watch the making of, because in order to tie in all the mouth movements and get that realism, they actually figured out the 52 sounds that we make in the English language and created a separate face that they swapped in and out as we made each of those sounds. And they used computers to time it and whatnot so that we got the frames and the camera angles just exactly right.
Mm-hmm.
So that was stop motion. And then came the computer age. And so we borrowed what we learned from those two, and we came up with computer animation. Keyframe animation is what we often refer to it as. And now all of a sudden, you're the keyframer. And we're letting the computer a lot of times do the in-between work. And so you will say, at this point in history, I want this person to be there, and at this point in history, I want that person to be there. So at frame 0, it's going to be there, and I'll put a keyframe there to lock in the rotation and position. And then at frame 30, I want this to happen, and I'll add another keyframe. So I will go and set the important things, and then I will create what are called tweens. Refer to it as tweens or tweening, coming from the in-betweeners. But the computer's doing that, and so we tell it through timelines how the position or the rotation will move over time, and we let the computer figure that out. Okay? So we don't have to go in and build every single frame. Point A is here. Over 30 seconds, it's gonna rotate 180 degrees. Position is gonna move up a little bit on the y-axis. Probably leave the X and Z alone, blah, blah, blah. And one of the fun things about Maxon C4D, which we're going to discover, is every single property of every single element can be animated. You can have, what is it, 50, 100 separate timelines just to animate a material. And another whole series of timelines to animate all the different properties of light. And another separate timeline to animate all the properties of the camera. And then each of the objects with, from the radius to the position to the rotation and everything in between, you can have separate timelines for that. And so we can have that many timelines all going simultaneously with their own set of timing.
How badly will that kill the render time?
Not bad.
Not bad.
Not near as bad as adding volumetric lighting and area shadows. Those, and reflections. Those things add a lot to the render time. The movement, not so much, and that's why we'll often preview in a low-res version while we're animating, and turn our shadows off and turn our volumetric lighting off, or cut back the shadows to a hard shadow so that we can speed up those render times just a little bit. Okay, so that's kind of the history of animation and where we're going. Cool? Cool. All right, then we're gonna start moving things.